This question here, and we're going to have a large triangle. Within this large triangle or wedge, because the wedge can move, you're going to have the table. Now, because there's friction here on a really basic level, before you even get into the technicalities of the whole thing, the table is supporting the wedge. Everybody agrees with that? The wedge is moving with an acceleration a to the right, yeah? Now, what does that mean is opposing the motion then? What's opposing the motion? Friction, which is going to be mu times n. Mu times n being the reaction force. So this n, finding out what n is going to be very important later on in the question. Now, we start like we always start. We just go in and we draw our, we're going to draw some of our triangles here, okay? So we starting off with this tan inverse, A equals tan inverse 3 over 4. Don't let that fool you, that's just a fancy way of saying tan A equals 3 over 4. Surprise how many people that can turn off, okay? And then sine A, opposite over adjacent being 4 over 5, cos A, nope, other way around, right? Sine A being 3 over 5, and cos A being 4 over 5. Are we happy with that? Now, how to draw your white triangle. Go directly down, because gravity has to act vertically downwards. Then draw a line that is parallel to the slope, and then stop when you're directly underneath the point, and that there is your triangle for white. This is angle A here, so what does that mean about this in here? Huh? It's A. So angle A, 5 mg going directly downwards. What's this one then? 5 mg cos A. 5 mg cos A is 4 mg. And then the other one is 5 mg sine A, otherwise known as 3 mg. Thank you. Because it's basically 5 mg multiplied by sine A, which is your 3 over 5. 5's cancel to give you your 3 mg. Okay, now that that's done, what we're going to be looking at next, guys, is do not forget the reaction force. I keep saying this, the reaction force, very important. Okay, let's start off by making our formula for the 5m mass. So 5m mass, and what we're going to do is F equals ma. Got to specify F. Now, our system states that F is affected by A. F and A aren't perpendicular to each other, which means that A's motion affects F. Therefore, what we have to do is we have to change A into the directions known by F. To do this, you do what's called acceleration triangle. I draw a big line. I pretend that's the acceleration, A. I draw it down here, and then I link it up with my to my slope, and then I go directly down. Now I do this in my head, or sometimes I might actually do it on the triangle itself. But what's neater is if you just take it down here like so, and there is your acceleration triangle. And look, A belongs in there anyway. Okay. So what side is this, guys? The hypotenuse is A. What side is this then? A cos A, otherwise known as 4 over 5A. And the other one? 3 over 5A, or A sine A. Okay, so quite easily done. And that's it done there. Okay, so there is your acceleration triangle. Done that well. Now, let's specify where we're going. We're going diagonally left down. What forces the 5m down the slope? 3 mg. Forced it diagonally left down. Anything else? Huh? No. MA, anybody? 5m for the mass. What about its acceleration? F going diagonally down. You led with it diagonally left down, so you have to start your acceleration diagonally left down and then take away what's diagonally right up. Diagonal right up is 4 over 5a. Multiply both sides by 5. Oh no need actually, never mind that. 3mg, 5mf, and then minus 4ma. And we'll call that equation 1. Where does the next equation come from? Equation 2. F equals ma again. Remember, the particle will give you 2 accelerations. Okay, so what's the other one then? Huh? Perpendicular. Okay, so perpendicularly down. Okay, what force is driving that perpendicularly down? The 5m particle. The answer's in here somewhere. Sorry? The 4mg drives it directly down. 4mg driving it directly down. Anything opposing that motion? R. Okay. And then what's m? M? Anybody? 5m. And then find the acceleration. Going diagonally right down. 3 over 5a. And then long and behold, 4mg minus r equals 3ma. And that's equation 2. What we have next is we've done our first 2 equations. So first 2 equations here. So you finish that off. Okay, so all I need from this, guys, is this here and this here. Okay, so there are my 2 equations. And next thing I'm going to do is just going to get rid of all this as best I can, and then just get rid of this little part in here. Okay guys, working on the wedge. Okay, so working on the wedge. How heavy is the wedge? mg. We have a reaction force. Call out whatever letter you want. I don't want to use S, so I'm going to use N. Okay, what else is acting on the wedge? Reaction force, because remember, it supports the missing thing up here by reaction force R. It doesn't take its full weight, it takes part of its weight because it's sliding off. Therefore, for every action there's an equal but opposite reaction. R is going this direction here. Now, our acceleration of our wedge, A. Okay? So, what it wants us to do here, guys, is it's saying, okay, I'm going in this direction here. Now, there's a problem. The only force that's not lined up, either perpendicular or parallel to A, is R, isn't it? R is the one that's causing the problems. Okay? So, to do R, what we do is this. If I was to make this continue down this triangle here, that's angle A, right? That's 90 degrees. That's 90 minus A in here. And then because this whole thing adds up to 90 degrees, it makes this part here A. And that's what we have to do with your reaction, okay? Now, what does that mean about this green part here? Anybody tell me what it is? R cos A, otherwise known as 4 over 5 R. And then this purple part here, R sine A, otherwise known as 3 over 5 R. Cool. Okay, now we go down and we make a formula. Let's start off with the wedge going right. So I can just rub out my F equals ma. I go wedge going directly to the right. Okay, everybody happy enough for that? Wedge going directly to the right. So, what's the weight of the wedge? Sorry, what force is driving it to the right? We forgot friction, guys. Friction opposing its motion to the left, because it says that the coefficient of friction between the wedge and the table is a half. So mu equals a half. Good call. So what we're going to have here is, first of all, what force drives it to the right? 3/5? 3/5 R driving it to the right. What makes it, what's opposing it? Friction is opposing it. So friction is mu R, or in this case, it's N. So it's going to be mu N, which is N over 2. Okay? Equals ma. What's the mass? The mass is m, and the acceleration is a. Now, there's another formula, and I described this to you the other day. It's called statics. Anybody remember why it's called statics? What you say? What goes up equals what goes down. You'll notice is that, see the wedge on the table, does the wedge sink down into the table, or does the wedge start floating in air? Doesn't do either. This means that it's in perfect balance, otherwise known as statics. And it's static in the up-down direction, i.e. forces up must equal forces down. Okay, what's the forces going up? Only one force goes up for the wedge. Anybody? Sorry? Who said the N? Okay, the N it is, okay? So you see that the N is the only force that brings it up. What goes down? Four over 5R and the mg. Okay? Now, knowing that, what we can do now is we can modify this. So we can substitute n. So I can find out what n over 2 is quite easy. N over 2 is going to be, just going to divide that by half, and just going to get a, what's it going to be, 2 over 5r? So just divide 4 over 5 by 2, you get 2 over 5r plus mg over 2, equation 4. Now, it wants us to find out what A and F are. Okay, so A and F. So let's just start with everything here. So I'm going to start off with equation 3. Equation 3 is now going to become 3 over 5r. 3 over 5r minus brackets. I'm going to put this in now. 2 over 5r plus mg over 2. And that's going to equal 3ma. Okay? Next thing, 1/5 r plus mg over 2 equals 3ma. I'm going to multiply everything by 10. I don't like fractions. So 30ma, 5mg, 2r. Just quick mistake in there, guys. It's actually ma, not 3ma. So I had to get rid of that there and that there. And instead of being 30, it's 10, right? Okay, thank you. So that's an equation there. Okay. Now this equation has a and r as its variables. It is minus mg over 2. On an absolute roll. So minus mg over 2, and that will in turn make that minus 5mg. So my bad there. Now, so that's 2r minus. I'm only going to find out. Okay, it is m. Okay. So 2r minus 5mg equals 10ma. So I'm going to make that minus 10ma equals 5mg. Now be aware here that the variables are ma. Ma is like your y value and r is like your x value. So it is a simultaneous equation. It's just that the y variable, so to speak, is m and a. But that'll cancel out at the end anyway. Now that's one equation with just RMA. Is there another equation that will have a similar trend? Just A's and R's. Anybody see it? This one here, isn't it? Equation 2. Everybody see equation 2? 3ma plus r equals, so it's the same thing as 3ma plus r equals 4mg. Okay, so just bring all that down here. There we go. Now, I have that sort of the wrong way around, so instead of 3ma plus r, I'm going to say r plus 3ma. Now, going to do here, multiply the bottom one by minus 2, leave the top one the same, and what we're going to get is, I'll just change it here, actually 2r minus 10ma equals 5mg, take away minus 2, minus 2r minus 6ma equals minus 8mg, minus 16ma equals minus 3mg. Therefore, A is 3 over 16g. So 3 over 16g. Yes. Okay, we're good. Next thing, find f. Which equation has f in it? It's equation 1. You're seeing it here. So all I have to do, bring it down. So, just do it this way. M's cancel. 3g equals 5f minus 4a. 4a is the same thing as 4 times 3 over 16g. What's that going to make that 3/4 g, isn't it? 3g equals 5f minus 3/4 g. Will somebody bring that over to your side? And it's going to be 3 and 3/4 g equals 5f. Will somebody divide 3 and 3/4 by 5 for me? F will equal, huh? 3 over 4g, thank you. Or 3 over 4g. Okay, so that is that is F and A. Now it gives us a last question. How far down the wedge would the particle travel in the time that it takes for the wedge to travel 1 meter? Wedge to travel 1 meter. Any ideas about this? Smells of UVAS, doesn't it? Or reeks of UVAS. Okay, 0. What's your acceleration, guys, for the wedge? Your acceleration for the wedge is your 3 over 16g. The distance you cover is 1 meter. To find out how far the particle travels, so the wedge travels in this direction here. So let's say the wedge covers the green distance, which is 1 meter. In that time, the particle might cover the blue distance, slipping down the face of the wedge, while the wedge is still traveling forward. Okay, so what we're going to do is we need to find out time. So we have a choice of phi equals u plus at, s equals ut plus a half at squared. That's your winner right there. So s equals 1 meter, ut is 0 because we don't know u, a half at squared, so it's going to be a half times 3 over 16 g. And then t squared we haven't got a clue about. Now, what we're going to end up with here, guys, is that's going to be 3 over 32. Bring it over to the other side and invert it. It's going to be 32 over 3g equals t squared. And then, and now I actually cross multiplied. So the in between step would be 1 equals 3 over 32g. So t squared. So I'll just cross multiply it up and down. Okay. Now that's done, guys. T equals the square root of 32 all over 3g. Okay, not the nicest number we'll ever get, but look, we're all with it. Next thing, gonna UVAST the wedge. UVAST. T equals 32 over 3g. S is what we're trying to find. Acceleration is 3 over 4g. U is 0. So let's do, once again, S equals UT plus a half AT squared. S is equal to 0 plus a half. Now we already know what T squared is, don't we? Up here. So it's a half 3 over 4g multiplied by 32 over 3g. Now, what on God's green earth is that, guys? Can somebody do that? It's a 3g, 4. Show us 4 meters. There we go. 4 meters.